Okay, so today I'll be giving you a demo on how you can create battery packs using MATLAB. Okay. Then you will get the same, you can say, demo in a visual way. That means there is another trainer. Okay, so another trainer is there. He will be showing you how to, you can say, create that battery pack that I have modeled in MATLAB. Okay. Okay. So if I say about MATLAB, so MATLAB is a system modeling software. So what is a system modeling software? Like if you want to create any kind of product, okay, uh, so that product involves different fields of engineering. Like if you want to design an electric cycle, then it has mechanical components, electrical components, electronic components, okay, tires, springs, a lot of things are there. But there is no workspace, okay, where you can integrate all these things. Like if you go for any CAD, that means you want to design the exterior, so you go for CAD software. But in CAD software, you can't simulate electronic items, okay. You cannot simulate how a motor is going to run properly. So you need another tool where you can simulate your motor, okay. But before doing all those things, you need one unique one software under which you can do all these testings, okay, all this assembly in a unified way. Okay. So that is what MATLAB is. It means MATLAB has nearly all the toolbox. That means it has mechanical, electrical, electronics, algorithm, and you can say coder toolbox to nearly design any kind of system. Okay. So most of the product designing companies, okay, those who go for innovative products, okay, not only aesthetically looking, that means even the technologically advanced products, okay, with complex electronics. So most of those companies use MATLAB because MATLAB is a place where you can start designing things from base without creating any CAD, going for any CAD software, any ECAD software, any CAM software. Okay, so this is the first place where you can test your, you can say, design. Okay, that means the design may contain electrical, mechanical, electronics, IT. Okay, IT means algorithms. Okay, anything. So you can see if I go to the library, you can see MATLAB has a lot of libraries. So inside those libraries, it has all the required toolbox. So you can see if I go for aerospace toolbox, in MATLAB, you can model spacecrafts, okay, propulsion engines, you can model pilots, you can model environment in which the propulsion engine or this, you can say spacecraft is going to fly. Then audio toolbox is there, like you have your Cortana, Alexa, so speech recognition, okay. So you can say you will be doing all those things using your audio toolbox. Then automated driving toolbox to create automatic driving cars. Remember, after MATLAB or after testing is done in MATLAB, that means yes, I have created a system that is working. Okay. And I can manufacture this system and create business out of it. Okay. Okay. So this is the first step to create any kind of system level engineering. Once the system level engineering is done, then you know what are the dimensions required to design a CAD. Okay, that means how much should be the weight, how much should be the length, width, height, and you can say areas of specific portion. Okay, deep learning toolbox, embedded toolbox, a lot of toolbox are there. Lot of toolbox. Okay. Remember, MATLAB is not only used in engineering fields. Okay, it is used in any kind of engineering actually. Financial engineering is also there. Biotech engineering is also there. Okay. Then a lot of you can say uh, areas are there where MATLAB is used. Okay, okay, a lot of areas are there where MATLAB is used. Okay. Okay. To Here we will start creating a battery pack. So how designers approach, or you can say how, let's say I want to, that means I'm working in a company that is manufacturing batteries. I need to create a battery pack with a specific form factor, with a specific, you can say, size of cell. Okay, and I want to test its charging and discharging characteristics. Okay, so how will I do that? So for that, first we need a battery. Okay, let's close this one and let's search for the battery. You can say MATLAB provides me with a lot of tools that I can use to create a battery. Different kinds of batteries can be created. Remember, not only one battery or one lithium ion cell. Batteries to be used inside mobile phones, batteries to be used inside smartwatch. Okay. Okay. Battery to be specific kinds of cooling batteries, or you can say space applications. Okay, a lot of blocks are there to create any kind of system. Okay. So now I have my battery. So what I want to do is I want to create a battery pack of 48 volt and 15 Ah of capacity. Okay. 48 volt and 15 Ah battery. Okay. I want to create a battery pack of this. Okay. So now how to do that? So if I double click on this battery module, we can see I'm provided with this window that has all the properties of this. So this block is a lithium ion battery. Okay. That means this block will discharge that until this is the battery. Okay. If I'll say battery block or this battery, I can select which type of battery to like. It can be a lithium ion battery, lead acid battery, nickel cadmium battery. Okay. Nickel metal hydride battery. You can select any kind of battery. Today we will go for lithium ion battery. Nominal voltage of each cell 3.2 volts. Rated capacity is 6H. Okay. Now initial state of charge I will start from 40%. That means I will charge my battery from 40%. Okay. That means my battery is 40% full, 60% empty. Now if I remember, if I go to the discharge, all these characteristics will be automatically calculated. Apply. You can see according to the properties I provide, all these things will be automatically calculated. And how these are calculated? From data sets provided by the manufacturers. Now I'll go for OK. So one cell is prepared. I want to create 48 volt 15 amps. Now, how many cells should I connect in order to get 15? So if you want to create 15 H, okay, so we will go for 12 page actually. You can say what will happen is that total current that will be available will be 15. Okay, 15 ampere. Okay. So we'll go for two batteries in parallel. Okay, so what I will do is I'll just copy all this and I will create a subsystem out. Because if you create a subsystem, then you can use this as a battery pack. That means you can copy and paste it anywhere you want. Because I was doing it on the first level. Remember, this is the first level. Layers should be there. Okay, remember, in any kind of system designing, layers are there. Like in your vehicle, you have exterior layer, interior layer, engine layer. Okay, so we perform layer by layer design. Okay, not everything is there in one layer. That will be very complex. So what we do is we go for layer by layer model. So in my sub layer, what I will do is I'll create my cells because your battery pack is there, sir. Because your battery pack is there. Okay. So I'll just delete this one and delete this one. Then, so this is my battery one. I'll name it as cell one. Okay. Lithium battery, lithium cell. So I'll just delete this one also. Cell, copy paste, cell two. Okay. Then paste cell three. So how I am doing it is first I will get my 15 AH. Okay. So how will I get my 15 Ah? By connecting both of the cells in series. Okay, sorry, parallel. So first let me connect this all these in series. Cell 2. So how many cells I need in series to create 48 volt? So I need, if I go for my calculator, okay, so I need 48 divided by 3.2, 15. Okay, so 15 cells I need. So I'll go for cell 2, then cell 3, we paste. Okay, so how many cells are there? You can say 12, sorry, 12, another one, 15. So 15 cells are there. Okay. So now how they will be connected? They all will be connected in series. So negative to positive, 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 negative to positive. So remember, I'm connecting all these cells in series. In order to generate how many voltage? 48 volt. 48 volt. And what is the voltage of each cell? 3.2 volt. Okay. So if I connect all these cells in series, so 3.2 multiplied with 15, it will become 48. Okay. So in order to increase the voltage, we connect all the cells in series. In order to increase the current, we connect the cells in parallel. So now my 48 volt is done. Now this battery pack will give me an output voltage of 48 volt, nominal voltage of 48. But what will be the current output of this arrangement? Only 6 Ah. Why? Because the maximum capacity of the cell in series is 6 Ah. That will, if I connect in say series, there will be no increase in current because it has only one path to flow. Okay. Now what will I do? In order to get 15 Ah, so I'll go for 12 Ah because the standard cell that are available will supply you 15 Ah. Okay. You connect them in a row. So now how these two will be connected? They'll be connected in parallel, positive to positive. Okay. And at the end, negative to negative. Okay. Now my battery pack is done. Okay. Or cell arrangement inside the battery pack is done. Next, what will I do? I'll connect some output ports. Connection port. So this will be my positive port connected to positive. Okay. Then another port I'll be connecting here. Okay. We name it. This is my negative. Then I'll just see. Now for now I'm getting a reading of only one cell. Okay. Remember in the you can say demo. Okay. So you can say in the demo the you can say sir or you can see your demo the trainer will be saying you how you can create or how you can connect all these cells to the BMS. Okay. Okay. No, no, it will be a you can say it will be a demo session. That means a physical demo. That means you can say trainer or you can say trainer is there. Okay. So he will be showing you how to build this battery pack physically. Okay. Here I am doing it in MATLAB. So first we do it in MATLAB. Then what we do, we build the cell. Okay. Then we test it. Okay. So I'll go for my out. I'll connect it to. Okay. Now you can see it is done. So now this is my battery pack. 48 volt. 15 AH battery pack. Now how to? Okay, sir, you have done. Let's test it. So now to test it, what will I do is I'll just connect a register, okay, and some you can say electronics, okay, in order to control the output properly. So there is some problem in my negative that is not connected. So now what will I do is I'll just connect a register. So for now, what I will do is I'll go for a um, variable register. Okay, I'll just keep it here. I'll just repeat this one. Variable register. So I'll connect it. Okay, so I need a current measurement device to measure how much current is flowing in the system. So I'll connect it to the positive. I'll connect this one here. Okay. Then I'll connect this one to the negative. Then I need a voltage measurement system. Then in order to see the output, we need to connect display. Display tab is used to see the output from a sensors. So from different blocks. I also want to see the output here. What are the outputs I'll be getting in here? My battery SOC, voltage and current. Okay. If the current is flowing inside the battery, it will be negative. If it is flowing outside of the battery, that means from the battery, it is positive. So inside means if it is charging, the current will be negative. If it is discharging, the current. So I need another constant block. The use of this block is used to, you can say, provide the value of resistance. So for now, I'll connect the 100 ohms resistor. The value of resistor is 100 ohms. Now I need another block. What is that? It is power GY. So why do we need this power GY? It is because in MATLAB we perform various kinds of system, or we design various kinds of system. Various kinds of systems needs various kinds of solution settings, solver settings. If we want to solve mechanical problems, one type of solver setting. Electronic problems, one kind of solver. Electrical, fluid dynamic, biotech, finance. Okay. If you want to solve different kinds of systems, you need different solver setting. Now, if you are designing a product where you have multiple, you can say systems. Okay. That means you have a mechanical system, a electrical, a electronic system, a algorithm, that is your IT system. Okay. So if you want to run all of them one by one, and if you will be changing the solver settings every time you run one system, it will be very hectic task. Very hectic. Okay. Hence MATLAB has provided us with this block. That is, if you just call this block inside your model, automatically for that model, the solutions will be updated in a certain way. Okay. Like power GY is used for electronic solver. Solver configuration is used for mechanical. Okay. And there are different other solvers for different solutions. Okay. Shall we press? Yes, it will like I have connected 12, but in real, if you just see, it will be 6, 15, 15 8. So because the BMS that we are using, it is a 15 AH BMS. So now what I will do is let me just run it. So I have resistance, so I need a discrete solver. Okay. Why? Because I have variable resistor. Okay. So discrete solver means that means it will stepwise solve. Okay. Like a continuous solver, this is a continuous solver, discrete solver. Perform simulation stepwise. Needed when you don't have a equation for a certain, you can say variable. Okay. Like if you have equation for that variable, okay, and that equation has no constraints. Constraints means there is no holes or there is no blank points on those equations. Then it will be a continuous. But if there is no equation, you have to set it, use it from a like from a sequence like 1, 2, 3, 4. Okay, then 2.5 like this. Okay, and that same value is going to continue for a certain period of time. Then we need discrete. So run. Okay, you can see it is running. Okay, you can see the current output from the battery is 0.151. So let's stop this one. I will do this. I'll just decrease the resistance so that we can see the drop in because current is very low. However, this 3.4 is each cell's voltage. Okay. And this 51.5 is the total pack voltage. Okay. So now what I will do is I'll just decrease this resistance a little bit. I'll go for 1. Okay. 1 ohm. So 1 ohm means don't think that 1 ohm resistance is that small resistance. Okay. No. 1 ohm 10k or you can say 10 kilowatt resistance. Okay, sorry, 1 kilowatt resistance. Like a very big resistance. So that can dissipate a lot of heat. You can see how my so what is the first thing? What is so that is your SOC. First one is your SOC. Let me just stop. SOC means state of charge of your battery. Okay. And what is the next one? Next one is your current. Okay. Then your voltage. Cell voltage. Okay, SOC current and cell voltage. Okay, so this is how we can create a battery pack and you can discharge in MATLAB. Now, next is what we will do is we will connect a switch and we will connect a charger or a higher potential to it. Okay, so I'll go for a switch. Okay, I'll go for an ideal switch. Okay. Ideal switch means if you give it an input of 0, it will be open, 1, closed. Okay. Okay, so 1 means it is closed. That means current will flow. 0 means current will flow. Okay. So what I will do is I'll connect a DC voltage source to it. Okay. Okay. A DC voltage source. DC voltage source means it is just like your charger. Okay. Your charger creates a DC voltage. Now, directly I cannot feed this DC voltage to the battery because there may be, you can say, uh, you can say, little bit of oscillations in the signal. Okay. So for that, I need a series RLC branch to, we can say, remove noise actually, to remove noise from my current signal. Okay. That means my current should be smooth. I have to connect this one, this, my series LC branch. Okay. Sorry, sir. Sorry, sir. I'll go for RL. Okay. Series RL branch. Okay. RL means there is a register and the connect. Then to remove fluctuations in your voltage reading, I need a series RC branch. Okay, I need a current measurement device also, directly where I can measure the direct output current. Okay, remember these are all the parts of your BMS. Okay, I make this one here. So now we can say if I switch it off, if I go for 0, you can say it will be switch off. That means my discharging won't happen, so I can charge it. The DC voltage source, how much I should be providing? 48 volt means nearly twice. Okay. Remember, this is the charging voltage generated by the inverter. Sir, you will say that your DC voltage charger comes with 48 volt. Actually, char 48 volt, it is compatible or it is for a 48 volt battery. Okay. Inside the charger, there are inverters, okay, or gates that, like, you can say, that can increase the voltage to a certain range for fast charging. Okay. Or for charging rapidly. Okay. So how much I'll keep it? I'll keep it 96. Okay, twice. Okay, nothing will happen. No. Okay, because your net potential will be how much? If this would have been a 0 voltage battery, then 96 is total 96 volts. But here, this is 39. You can say my battery pack, you can say cell is 49 volts at how much? At 39% SOC, my battery cell voltage is 49. So 49 minus 96. Your 96 minus 49. 47. So 47 will be the net voltage. Okay. This will charge. If I use a 48 volt output, so what will happen is my battery is 48 volt. So when nearly it is at 98% or 95%, it will stop charging. Or the charging will be very, very slow. Why? Because the potential difference becomes 0. Okay, at near 48 volt. So we keep the potential higher than the battery voltage. So now if I run it, you can see I'll see the SOC, or you can see the SOC of the battery will increase. Okay, you can see the battery is getting charged. These are all done by the PMS. Okay. Okay, so this brings us to the end of the first uh, part of this total demo session. Okay. So you know how to create a battery pack. Okay. That means how to physically test. So now this testing, I know that yes, my battery pack is providing me the required current, and you can say there is no, you can say, and also I'm seeing a good increase in SOC of the battery. These are some leakage current. Leakage current won't. If I just connect a proper ground, there will be no leakage current. Okay. So now my battery pack is working. That means it is discharging properly. It is charging properly. So now we will build this battery pack physically, and we will connect it a BMS to it, and we will measure all the parameters. These parameters. So whether it is same or not. Okay.
Mr. Jyoti can take over this. Hello, very good evening, Jyoti sir. You are in mute, sir.
Sorry. Okay, good evening, everyone. So all of you have just seen a demo of electric vehicle battery pack manufacturing in a MATLAB. So whenever in industries, whenever you go, they just simulate it in the MATLAB and simulating. After that, what we do is we bring that simulating like drafts or simulating PDFs or CSV files to the manufacturing setup. After they are, whenever we go for the manufacturing setup, first we see what is the in the drafting sheets that already you have seen that Mr. Deepesh sir have been shown in the MATLAB and Simulink. The same thing we decide in which type of cells we'll be preferring. Okay, so there are a lot of cells we'll be seeing today. So I'll be showing you some of the cells. So actually in industry, all of you able to see my camera? So I'll be requesting everyone to ping my cameras to their wall so that you can able to see the whole process actually. All of you able to see? I guess. Anis, is it visible?
Yes,
Yes. Is my cells are visible, right? Back camera is on. I'm unable to see it actually. Sorry. Okay. So all of you able to see my back, right?
Yeah, it's
Yes.
visible.
So here we have different categories of batteries, which we can, like as sir showed you about 48 voltage, 15 ampere battery pack, which is like nothing but it will be of 12 voltage only. The lower cutoff power will be 12 voltage only. That we can achieve in different battery packs also. So here I have a cell which is 32,700. That means 32,700 means in every cells come with a dimensions, right? Every cells comes with a dimension, because whenever we choose certain cells, what happens there, we can visualize like there the specific density, specific energy, these also matters. Okay, this also matters. For that process, we need to choose specific a specific battery. So this in my hand, if you can visualize, this is a 32,700 cell. What is this 32,700 means? 32 is the diameter of the cell, and 700 is the 700 mm is the this length. Okay, this is the length, means 7 centimeters is the length. So this is called a 32,700 cell. Then we have another type of cell which is 18,650. This is a 18,650. What is 18,650? 18 is the diameter and 650 is the length of the cell. Another cell also we have, that is 32,140. 32,140 means 140 is the length and 32 is the diameter. So these are the certain cylindrical cells that we use in electric vehicle battery pack manufacturing process. So after testing these cells, so what we'll be testing in these cells? So generally we'll be testing its impedance. Okay, then we'll be testing its voltage. We'll be continuously charging and discharging so that we can record a time. How much time it takes to charge for each cell, how much time to get it like it discharged, what are its highest peak value, what is its lower cutoff value. So all this value will be checking it, and what is the temperature. So before manufacturing battery pack, we'll be checking out the cells here. After checking it, then we'll be bringing it to the to the workstation where we'll be building it. So already I have arranged the cells. So here we'll be building a 48 voltage 12 ampere battery pack. Okay, So for 48 voltage battery pack, so as sir said, we have 3.2 cell characteristics. Means this cell will be able to provide us 3.2 and 6 ampere of current, 3.2 voltage and 6 ampere of current. Okay. After testing it, we'll be testing the IR values and everything in the cell testing machine. Then we'll be bringing it to this system. Then we'll be configure it whether we have to build in a series or in a parallel. You know that in series what happens, the voltage will be increasing, the voltage of the battery pack will be increasing. If we connect the cells in the series, the voltage will be increasing, and if we'll be connecting in the parallel, the current will be increasing and the voltage remain constant. Understood everyone? If you are able to, if you have any doubt also, you can ask me in the chat box. Okay, instantly you can ask me. I'll be there in the chat box to answer your queries. Okay, so after this, knowing about the connections and like whether we have to put it in a series or whether we have to put in a parallel, then only will be configure it. So as you are preparing a 48 voltage 6 ampere battery pack here, a 48 voltage 6 ampere, 12 ampere battery pack here. So what we need to do? We need to configure in a such way that our battery pack will be taking smaller area and will be giving higher efficiency. That is called your we can say that is specific density that we specific density that is required for the battery pack that we will be assuming. So here what we did is, first we'll be connecting. What I did is, here I have taken 30 cells because my each cell is giving 6 ampere, okay, and 3.2. So if I'll be connecting 3.2 means for making a 48 voltage, I require 15 cells. So for 15 cells, if I'll be taking 15 cells, I'll be matching my voltage, but I'll be not matching my current because I require 12 ampere of current. I know that if I'll be connecting the parallel, then I can get a 12 ampere of current from this. So what I did is, I'll be taking 2 cells as a module. Okay, 2 cells as a module for making a 12 ampere battery pack. Okay, means if I'll be connecting these 2 cells in parallel, okay, these 2 will be giving me how much? 12 ampere. Okay, and the voltage will be 3.2. Then again these 2 cells, if I'll be connecting this negative port of these 2 cells, then how much value I'll be getting? Here I'll be getting 6 voltage, like 6.2 or 4 voltage and 12 ampere. Like this, I'll be connecting all the cells. Everyone understood? If you have any queries, please ask me. On the later part, again, we'll be heading to the next step. Now, what I'll do, I'll be connecting these 2 cells. So for that, what I'll do, I'll be just using a spot welding machines. So generally in industry, they use this spot welding machine for the connecting of the material or the cells in a series or parallel. I'll be using these nickel strips plates to connect it in the series and in a parallel, and after that I'll be using this to weld it properly. Okay, so here you can see I have long these strips, so I'll be cutting it down. I'll be cutting it down in a small pieces so that whatever requirement will be, I'll be connecting on that base. Okay, so here you can see, here I have to put this in a series connection, these 2 in a parallel and these 2 in the series. Okay, so you'll be thinking, sir, how it will be connected? So what I'll do is, I'll be connecting the series as well as the parallel simultaneously. I'll be connecting. Okay, so these are the pen nib. Okay, so here what I'll do is, I'll be just putting it to the nib and I'll be pressing it. So here you can see, here it is been welded. So now these 2, if you check, okay, these 2 is been connected in the parallel connection. Now these 2 cells become one module. Okay, these 2 cells become one module, which will be connected to the next module in a series connection. So here I am connecting a series connection. Okay. So you have to solder it properly. Okay, so that it won't get loose. Okay, so after that you can check it by using this tip. You can check it whether it is sold properly or not. Okay, so you can see it is in soldered properly. The next step is that I'll be connecting these four in a series and parallel connection both. So first I'll be connecting with this series and this series, then again these two in a parallel connection. Okay. So again, you'll be asking me here one doubt, sir, why not we are connecting these two? Okay, if we'll be connecting these two as well, so what will be coming? This is also going to increase in a series. Okay, so in the downside, I'll be connecting in a series. If I'll be connecting here, it will be becoming a like mismatch. Okay, or the current will be blocked, or the voltage will be blocked in between these cells only. Okay, in between these 6 cells only. Okay, so that for making it in a loop condition, I'll be connecting these two and these two in the backside of it. Okay, in the backside of it, I'll be connecting. So this is connected. Again, I have to connect this also. So this is all about the connections and safety. Okay. So here will be Simon. If you have any queries also, you can ask me. Okay. No need to, because it is like it will be taking some time, certain times. So if you have any queries also, you can ask us. So now these four, okay, these four, what I did is I have connected these two and these two in a series connection, and these two and this two in the parallel connection. So what happens? This will be providing me up to 6.4 voltage and 12 ampere of current. So again, if I will be connecting these two, okay, these two, the first and the second in the back here in this side, what will be the voltage? It will be again increased to 9 point something. Okay, it will be increasing to 9.6 or 9.8 in the backside of it. Okay, if here I'll be connecting these two, okay, these two I'll be connecting here, it will be becoming 9.6. So how the current will be passing? You know that from the negative side, the current will be passed. This is the negative side. So here it will be going in a loop condition and it will be delivered in the positive side. So here it will be connecting the 12 ampere from these two and 3.2 voltage. Then again here it will be going. Again here it will be added to because these two are already in 12 voltage. So again the voltage will be added here because it has been connected in the series. These two are connected in the series. That is why it will be connected. It is connected in the series, so it will be adding the voltage here. So here this 3.2 and this 3.2 will be 6.4 and 12 ampere. Then here you can see here these two will be connected in the series. In the backside of it will be connected in the series. So here this will be connected, and here 6.4 plus 3.2, it will be 9.6, and again here it will be transferred to here and you can get the output. So all the cells will be connecting in this process. Okay. So here also the same process will be following. So here you can take it will be a time taking process. So here I have connected in the series again. Okay. Again, sorry, in parallel I am connecting. these two cells to make it a 12 ampere, to make these two cells 12 ampere. Then what I'll do, then again so again these two I'll be connecting in the series so that the voltage will be added up. Okay, the voltage will be added up to it here. Okay, so here what I'm doing is again the same thing I'll be doing, parallel and series. Parallel and series is the same process will be continuing. Okay, the same thing will be continuing. That is series and parallel. So I am not doing in the backside. After completing this, I'll be moving to the back of it. Okay. Okay. So it's the same way, whatever we have connected, so we'll be connecting whatever we have done in the like in the beginning, whatever done, we are connecting the series and in parallel, same concept will be following here also. Series and in parallel. So I'm connecting the setups by parallelly first, so that we'll be able to get it properly. Okay. So these are the parallel connection I did. Now I'll be going for the series connections. Okay. So here what I'll do, I will doing it in the later part. So whatever I have completed, I'll be doing it in the beginning. Okay. So you can see here, we have connected this line. Okay, we have connected this line. If I'll be connecting the same here, what will happening? It will be in a same module, means it will be giving me 6.4 voltage and 12 ampere. That is why I need to break this. So what I'll do, I'll be connecting these two, and not with these two cell will be not connected to these two cells. This will be connected to these two cells so that we can break it easily. Okay. So the power from that side, it will come directly to these cells. Okay, not to this cells. Okay, understood? Okay, thank you. I guess everyone getting understanding it. Okay, thank you guys. I hope everyone able to understand. So yes, Further, any queries also about any topics related to the electric vehicle also, you can ask us. Let me check this. So be careful whenever you are cutting these metal strips. So what happens if certain metal strips will be remaining in the floor? So maybe the spark will be there or a short circuit within the batteries will be happening. So be careful while you are doing it. Okay. So this is the same technique in the industry that follows. Okay. For more certain things, you can also visit our labs, that is in Hyderabad or in Bhubaneswar. You can come down and you can visit our labs where our faculty will be there for the practical demos. Okay, you can come down and you can avail uh, this. And if you are not able to come down, you can visit our websites and our YouTube channel in the in the YouTube. You can visit there and you can see our recent innovations or many classes that already you have missed it and you want to do. You can visit there and you can see. So as I'm talking about the battery pack, so in industry they use 13 parameters for the choosing any right type of cell or any right type of battery packs while they prepare it. So what are the parameters? First is the cell voltage. They need to check about the cell voltage, because as if the cell voltage will be in a higher configuration, like like I'll be giving an example. The cell voltage of lead acid battery is 2 volt. Okay, means the maximum voltage that the lead acid battery can give is 2 volt. So that is why you can see the cells that has been used in the lead acid battery are too heavy than the lithium ions, because in the lithium ion category the cell voltage is from 2.4 to 3.7 or 3.8. So in that category, you can see the cell voltage for the these the cell voltage for the lithium ion voltage, like lithium ion battery pack. That is why the lithium ion battery pack are so much lesser in weight and gives more efficiency, because the cell is of more configuration, means the cell is carrying large heavy voltage. Okay, like from 3.2 like I just said you, it is 2.1 to 3.7 or 3.8 it will be carrying. So this is why the first configuration I said you, that is cell voltage. Okay, then the second is specific density. Okay, specific density. Okay, sorry, specific power and specific energy, not specific density. It is specific power and specific energy. So when you go for specific energy, what is specific energy? Specific energy, that means how much energy your battery will be carrying in the cell. Means if the cell dimension is 3.32 and sorry, it is calculated by the It is calculated by watt per kg. Means if your battery weight is certain 10 kg. Okay, if the battery weight is 10 kg and your battery is able to provide you a power of 720 watt or 1000 watt, then it is called to be as your specific energy. Means it will be calculated by the weight of the battery and power that has been provided. Okay, so as our cell voltage is higher in our lithium ion batteries, as our cell voltage is higher in our lithium ion batteries, so what happens there? The weight also will be becoming less, because lesser weight we are using, means less weight, less cell we are using. See, just a calculation. Just take your cell, means if you want to make a 10 voltage battery pack. Okay, 10 voltage battery pack. Okay, so if you are taking lead acid battery, so how much cells you'll be using? 5 cells, because 10 5 cells and each cell is giving 2 voltage. Okay, 2 voltage, that means 5 into 2, 10 voltage you will be getting. Okay, for 10 voltage you will for 10 voltage you are using 5 cells. Okay, maybe for each cell should be of 100 gram or 200 gram. Okay, so if you are using 5 cells, then what will be its weight? 2 into 5. Okay, means 1 kg approx. Okay, the same scenario you calculate with the lithium ion battery pack. Your lithium ion battery pack is of 3.2. Okay, maybe 3.2 you can take. Okay, 3.2. That means 3.2. If you want to make a 12 a 10 volt battery pack, then you will be using approx 3 cells. Approx 3 cells you will be using. Okay, if you'll be using 3 cells, and in the lead acid you are using 5 cells. And here also you can configure the same thing. If you're configuring like the weight, if you're calculating with 200 gram, each cell is of 200 gram. Okay, the same that is calculated for the lead acid battery. If each cell is 200 gram, then 3 into 2, that is 600 kg, 600 gram. Okay, means here you are using 600 kgs of lithium ion, 600 gram of lithium ion to make a 12 volt battery pack, and they are using 1 kg of lead acid to make a 12 volt battery pack. So that is why the efficiency of lithium ion battery is compared to the weight. If you compare to the lead acid battery, if you with the lithium ion battery pack, you can see here the calculation says that the lithium ion batteries takes lesser weight to deliver the same efficiency as lead acid. Means if lead acid, we are using the lead acid battery, it will be carrying more, or the battery will be of more weight, and the lithium ion will be the lesser in weight. Okay, that is why most of the vehicles nowadays they are preferring lithium ion, so that in the lesser weight they can manufacture the vehicle. The vehicle weight will be less. Okay, understood? Understood? Okay, then we go for your charge density. Okay, means charge. If you come across the C rate, so some people say that we our battery is 3 C rate, our battery is 1 C rate. What is that? Have you ever questioned yourself what is that C rate? The C rate is that in 1 C rate, yeah, if you have any like, if you have already know about the C rate, you can give it in the chat box. Is like you can say your answer. Yes, I know the C rate, and what is that C rate? If you can answer it, it will be a good for your friends to know about the C rate, or else I'll be saying it. Yes, 1 C rate means 1 amps of current in a hour, means in a particular hour. Okay, in a particular hour, if your battery is charging in 1 current rate, means in a 60 minute, if your battery able to give you 1 amps of current, then it is called to be as 1 C. Okay, if your battery will be discharging, like certain, if your battery will be able to discharge, then what will be the C rate? What will be the C rate? In a 60 minute, if your battery pack is using 12, suppose if you're in a, suppose your battery pack is of 2 ampere. Okay, if your battery pack is 2 ampere, then it takes how much? And it is 1 C. Okay, 1 C. Your battery pack is of 1 C, and your battery pack is using 2 amperes of current to discharge. Then what will be the C rate? Means in how many minutes it will be get discharged? How many minutes it will be taking to discharge? If your battery pack is 1 C rate, okay, and yeah, 30 minutes. 30 minutes, because here what happens, here the current is more and the time span is the same. Okay, that is means in 60 minutes, what happens? We are just discharging 2 amps of current. That means when the discharge will be there, it will be calculated as 2 C rate. That means our battery pack will be discharged in 2 C rate. Okay, so this is the logic that you follow. So this is also plays a vital role whenever you choose or you have to make a battery pack. This will be playing a vital role whenever you make a battery pack, or you like you just calculate it, because the C rate will be what it will be determining how fast you can charge and how fast you can discharge, how your battery will be getting discharged. Okay, according to that only your charger will be decided. Now you'll be asking me, sir, you are talking about the battery pack making. Okay, what about to charge it? How we can charge it? So always remember, whenever you are preparing certain battery packs, okay, whenever you are preparing certain battery packs, there what happens? Your charging efficiency, the charging efficiency should be 25% to 60%. That means if you are using a 12 ampere battery pack, 48 voltage 12 ampere battery pack, then your charger should be 48 voltage and 25% of the current. That means 12 amperes, 25% is approx 3 ampere. So 48 voltage, 3 ampere charger you need to carry with this 48 voltage battery. Okay, understood? So you can see here, our battery pack has been prepared here. Okay, means the battery pack has been soldered properly and it has been prepared. So the final negative will be from here. The final negative will be from here, and the final positive will be from here. So how the current will be flowing? See, here these two is providing how much? 12 ampere, because I have said you connected in the parallel. These two are providing me 12 ampere. Here, the 12 ampere will be providing with 3.2 voltage. Okay. Now what happens? Here you can see these are connected in the series. These are connected in the series. So what will be happening? Here, the 12 ampere will be going and the voltage will be doubled. As you are connected in the series, the voltage will be doubled. So it will be 6.4. Now this 6.4 will be coming to the positive side. Here also in the positive to negative, this is connected with the same 12 voltage, because we are not connected any other module. We are connected to two cells. We are not connected in other module. So these two will be connected in the series connection. So here again, the negative it will be coming, because from the positive to negative it will be coming. So here whatever it will be again added to 9.4. Okay, this is 6.4, here 9.6, like this it will be continuing. I'll be showing you in the multimeter. So here I have just used a multimeter so to show it. So here you can check the values. Okay, the first cell that has been connected, you can check how much, approx 3.2. Okay, 3.2. Then again here I'll be connecting because it is coming like this. So here in this, how much? 6.5. Again, from this negative to this positive, how much? 9.8. Again, this positive, because in a loop condition is it is going on in a series connection and in a loop condition. So again here I'll be showing you. Sorry, you can check it here also. Okay, how much? Sorry, here 13.1. Then again here from here to this loop. Okay, 13 point, again 3.2 is been added, 16.3. Again 3.2 will be added. You can see 19.6. Again what happened? 3.2 will be added, 22.9. Okay, again here also you can check. I'm checking in the downside, it is 26.2. Then again in this side you can check, it is 29.5. Again here you can check it, 32. So everywhere 3.2 is been added. Okay, 35. Again here it will be approx 39. Then here it is 42. Okay, then again here it is 45. Okay, it is 45. Then again here it is 49. Okay, and okay, it is the last cell. So that is the 49. You'll be asking, sir, as we are making, it is a 48 and 49. So like how it is become 49. So what happened is, whenever you are preparing the battery pack, 48 is the average value. If you come across 48 voltage, 60 voltage, 72 voltage, that are the average value. Average value means the battery cells will be having one peak value and another cutoff value. What is the peak value? Peak value means the battery will be, when you will be charging it, it will be going for certain limits. Okay, for 3.2, the peak value will be 3.6 or 3.8. And the cutoff value is 2.1 or 2.3. Okay, so whenever this battery pack will be fully charged, it will be able to like go up to 54.6. Okay, and the cutoff value will be 43 to 38, in between 38 point something to 42 point something. In between that, the battery charge and discharge or the battery will be performing. Means the 42.1 and 54.1, in between these, the charge will be 100% to 0%. Okay, understood? So now here we'll be using the BMS. Okay, here we are using a smart BMS. Okay, smart BMS, which will be from 3S to 24S battery for using battery pack. So here, as we are using for as we are using 15S, so I have connected the 15 connections. Okay, so now we'll be asking, sir, how we can connect it. So here we have certain wires, connecting wires. We have connecting wires of it. Okay. We have connecting wires. So if you count this connecting wires, how many wires will be there? Here 15 wires will be there because 15 modules we have created. For each module, we will be connecting one wire, so that from each module, the BMS will be calculating what is this current and how to balance it and how to take the power. So it will be monitoring for each and every cell. So for 15 modules, as we have prepared 15 modules, so you can count on it, 15 modules, 1, 2, 3, sorry, here 1, 2, 3, 4, 5, 6, 7, and here 8, 9, 10, 11, 12, 13, 14, and 15. Okay, so these are the 15 module we have prepared. So again, you will be counting 3, 3, 6, here 7, 8, 9, 10, 11, 12, 13, 14, and 15. Okay, so these are the 15 modules we have prepared. Okay, so here first we will be connecting from the negative side. Here first we'll be connecting from the negative side. So this is my one black will be the negative. So here where the negative wire will be connected, where there will be our final negative. So this is my final negative. Okay, so this is my final negative. From here I'll be connecting this negative wire. Okay, so I need to just peel it off the wire. Okay, I need to just peel it off. uh, dip some flex in it. Okay, flex in it, and I'll be using soldering wire for connecting here. So what I'll do is I'll be applying certain flex in it so that the soldering will be good. Okay, the soldering will be good here. So each is module will be connecting. For every module will be connecting one BMS. Okay, so here first is the negative point I'll be connecting. So this is my negative. Okay, I'll do some, and I'll be apply some adding materials here. Okay, so that it sticks properly. So here we can add it. Okay, this. So the negative has been connected. Okay, the negative has been connected. Now the next wire, the very next wire of the negative side, the very next wire of the negative side will be connected to the positive. Okay, here, because this is the first positive. From here the negative will be starting, so this will be my first positive. So here it will be started. Okay, the very next wire will be the positive one. Okay, so here it will be started. So again, so this side I'll be putting it. So again, I have to add certain mix in it. Okay, then add some soldering materials here. So here you can add it because this is a rough patch. It will be taking some time to stick it. Then the next one, okay, I'll be just putting glues here so that it will be taking less time to connect it. I'll be putting it some. Okay. So first, what I'll do, I will just give some adding material so that the soldering will be easy for us. Okay. So here I'll be keep on adding the materials. Okay. So here what we'll do, the third wire. Okay, so third wire from the BMS will be connecting to this positive. Okay, this positive. So here we'll be connecting it. The third is connected. Then the fourth will be here. Okay, the fourth will be here. So the fourth wire, that is because it is connecting in a series. So the fourth wire will be connecting the fourth module. Okay. The fourth will be connecting the fourth module. Then the fifth, same goes with the fifth also. The fifth will be connecting the fifth module. Fifth. Then we'll be connecting the fifth here. Fifth went. Then the sixth one will be connecting the sixth one will be connecting here. Sixth. Then seventh. The seventh one. It will be. You have to be a little bit careful when you connect the BMS. Okay. So this is how the BMS has been connected. So this is a modular based BMS. So that is why in the every module we are connecting. Okay. Okay, here the 1, 2, 3, 4, 5, 6, 7. 7 went. Here the very next one, 8. Okay, here the 8th one, I'll be connecting to here. Okay, the 8th one I'll be connecting to this module. Okay, eighth one, then 9th, then 9th to here. Okay, ninth, then the 10th will be 10th, then here 11th. Okay, let me check. I'm a bit confused here. Yeah. Just give me a second. Connected to this here. Okay, the very next one will be connected here. Okay, then after that it is same in the alternative, this area, because as we are doing in a series connection, so this is our alternative we have to make. Okay, this is done. Then same goes with others also. It will be here. Be here. Then again another one. It will be here. Will be here. Then this will be here. This is the 14th module we are following. So 14th module will be here. Okay. Then the last module. The last module will be in the final positive. Okay, the last module will be the final positive. Okay, so like this, from these wires, the BMS will be going to monitor all your cells performances, like the cell temperature, cells SOCs, cell DOD, or it will be balancing the cells. So if you want to measure also, you can measure it from here. So somewhere, guess from two side here. Uh, so so here also you can measure the values. Okay, from this side also you can measure the values. So here I'll be putting the multimeter here. You can check it. So here I'll be keeping, because the negative is same for everyone. So negative point I am keeping it fixed, and again I am transferring. So 3.2 again you can see. Next one will be 6.3. 1 I am just increasing here. Okay. Then 9.8. Then 13.7, 13.1. Then 16.1. Okay. Then 19.6. Then 22.9. So same values you are getting. 26.2. 20, yeah, 29.5. Same values you are getting. 32, 35, 39, 42, and 42. Here 45. And the last one, here it is. So the last one, here we are getting. So this is one way you can check, okay, whether you have connected properly or not, or else you can do like this also. Like alternatively, you can check here by putting the knobs in the B side. So 3.2, again I am transferring it 3.2. So like this also you can check each and every cell's voltage values. Okay. After this, you have this BMS. So this is a 15S BMS. This is a 15S BMS. So here we'll be connecting these ports. Okay, here we'll be connecting these ports, and here will be okay. Then you have two wires. Okay, what is the work of these wires? Two wires. This will be connected to the negative. So here you can see here we have B minus and C minus. What is this B minus and C minus? That means the BMS is saying that you connect me in the negative. The B is battery negative. Okay, the B is the battery negative and C is the connector negative. That means the battery means it is asking me that it is the battery. You connect it in the negative side of the battery, and here you can connect it the negative side of the connector, means where the output or the input will be there. Okay, these are the two things we will need to connect. So here this, okay, first what I'll do, I'll be putting it here, putting it in this this side, and here also we can put it. Then here we'll be connecting the negative side. So which one is my battery negative? So this one is my battery negative. So this I'll be connecting the negative side. And here what I'll do, I'll be connecting the output area. Okay, this I'll be connecting the output area. To see the reading, what I'll do is I'll be just moving my batteries. So this I'll be putting it in the negative side, and here I'll be asking someone. So here my negative will be connected in the connecting negative, and here the output. Okay. Okay, so here the output. You can check in the BMS also the same output I'm getting, that is 49.0. So this is all about your BMS and your battery pack manufacturing. So here what happens, the BMS will be able to connect my or transfer my power, the negative power from my BMS only. The battery will be transferring the negative power through this BMS, and it will be giving to the output system. Okay.